And first of all, I'd like to know who of you has already built a single-page application with React? So quite some people, I would guess the majority has raised their hands. Great. So I'm working for Doctronic. It's a software company based in Western Germany. It's a small company. Most of our customers are like publishers, so we do lots of text processing stuff and text publishing stuff. And we have a Clojure team over there, so people that do most of their time Clojure and ClojureScript, for example. And in the last couple of months, we have built around, I guess, 5 ClojureScript single-page applications, and we have used different wrappers around React and have gained some interesting experiences, and I'd like in this talk share them with you. So first, a short recap on the programming model of React. So you define a hierarchy of components. Every single component is responsible to render a piece of your front-end state into DOM elements. And logically, every time that something in your state, in your front-end state changes, the whole UI gets re-rendered. So you can see these hierarchy of components as one big composed function producing DOM elements from your front-end state. And if you would implement such a thing naively, that would be very expensive. And this is the crucial point where React comes in. So with React, you just create virtual DOM elements, and React is then responsible to find out what exactly has changed and what it has to merge back then into the real browser DOM, which it does very efficiently. So this gives us a much better way and a much simpler way of thinking about UI development. And we have in ClojureScript lots of React wrappers, I guess at least 4 or 5 or 6 or so, and there are even some more that I'm certainly not aware of. And they do solve some of the interesting problems, but not all of them. So today I'm talking about how to organize your state in a React-based single-page application and how to do synchronization of state with your remote backend. So let's first start with the organization of state. Your components clearly form a hierarchy, but what about your state? So you have basically 2 options. You can choose, for example, that every component should have its own piece of state. So it should keep its state in its own atom. And this immediately raises questions about consistency of your front-end state. And it spreads basically mutation all over the place in your front-end. So this is not one of the best options, but it is certainly very flexible. The other option is to put everything in one single big atom, but this also creates some kind of problems, and we will now examine a little bit closer what those are. So what do you do when you have the same piece of information somewhere in your state that you want to render at very different places in your component hierarchy? In the worst case, you have to just pass down the whole state into each and every component just in case it needs to render something of it. So this could cause very rigid coupling between your components and the structure of your state. So this is one of the interesting problems that you might get when you work with state in one big atom. Another problem are what I call structural mismatches between your state or what you get from your backend and how your component hierarchy looks like. This might cause you to recalculate expensive transformations over and over again every single time something changes in your state or you receive some data from your backend. So this is also something that might be a problem for you. Then we have a third problem, which I think is very interesting, and I call it unpredictable data needs. So just assume you have an application where the users can very dynamically decide which piece of information they want to see and which one they want to hide. So it's basically impossible for you to predict what kind of data is needed to request it from your backend. So you might end up building, for example, hundreds of endpoints to get always the right data, or the alternative may be to just load the maximum amount of data that the user might want to see into your application, which is then very inefficient. And last but not least, we have a problem which is concerned with updating your state. So, for example, you have a component that renders an input field and the user types some text. And then you have to decide who should then update your state. You can choose to either have the component update your state locally and directly without any interference with other code. But this is certainly not the best option, because usually you might have some cross-cutting concerns like validation that you also want to solve. And if each component does it on its own, then perhaps this is not the best approach. The other option that you have is you just let the component just create an event, which is a map with some data from the event that it received from the JavaScript environment, and put this map into some kind of channel. This gives you a bit of, it gives you more flexibility, and it decouples your component, which is basically concerned with rendering DOM elements from your presentation logic. So it might be a bit overwhelming to see all these problems when you start with a single page application. So you might want to consider if a single page application for your case is the best option. But once you have decided you want to build a single page application, you need some guiding rules or some ideas where to start. And I suggest, and we use in our teams, these basic rules here. So the first idea is to keep front-end state in one single atom, because this helps us greatly with consistency, and it also is very nice when you have to debug your application and need a single source of truth to look at when you search for problems. And then I'd like to keep the components very stupid. So one thing is that you keep the presentation logic, the update logic, any kind of validation, for instance, you keep them outside of your components. And then next thing is you don't want the components to know exactly where they communicate to if they send events. So in our case, we usually provide a communication channel, so a core.async channel, for example, to our components. So they just don't know exactly where they communicate to. This gives us a great deal of flexibility. And furthermore, you want to avoid any assumptions that your components makes about your environment or about their environment. For example, they should not know exactly where they look at in the state. They should not know where exactly they communicate to. The more you are able to reduce the assumptions that your components make about their environment, the more easier it gets to reuse them and some other places that you did not anticipate in the first case. And finally, I'd like to have all my presentation logic in a very uniform way. So they should just form a set of functions, and each function transforms existing state and an event to a new version of state or a channel, for example, if you have to do some remote communication in between. And if you try to follow these rules, you quickly end up with this idea, which I call the big loop. And if you look, for example, into ORM-Next, or if you look into Reframe, then you will recognize that they also follow this idea of the big loop. So we start at the front left with the application state, and you have then your defined component hierarchy, and this creates a representation of your state as DOM elements. React is then responsible to render this state or render these DOM elements into your browser DOM, and also emits the event handlers. And those event handlers that your components contain then just pick up the event that they receive in the callback and then put it into a channel that the components have received as parameters, for example. And on the other end of the channel, there sits a dispatcher, which decides upon perhaps the ID of the component or perhaps upon the data within the event, where or which piece of presentation logic has to be run to update the state. There is a very important idea currently implemented in OmNext, which you should be aware of before you start to make concrete decisions in your own project. This idea is called co-located queries, and it essentially solves the problem of unpredictable data needs. So the idea is that every component keeps its own query. It's just a bit of a query. And then you provide a parser that understands all these queries and decides where to get the data actually from. So it might get the data from a remote backend or from the local state. And this really also solves the problem of transformation, because by definition, the component hierarchy defines how the data is structured, because the query looks like just the component hierarchy. And so the data that is returned will match very naturally with the component tree that you have. But be aware that this approach does not solve every problem, and it perhaps brings a new problem, which is called duplication of data. So before you try to edit those pieces of state that have been duplicated in the answer or in the response to the query, you might need some normalization to make sure that you only update one piece of state. So that's another problem. OmNext solves some of these problems, but the programming model is overall a little bit rigid, and you really have to decide if this is the one for you. So I would recommend that you first make up your minds before you start picking any React library if unpredictable data needs is actually a problem that you have. So in many simple forms over data applications, like what we, for example, do at Doctronic, there is a great chance that your top-level components can very well decide where they have to get the data from, and then they push the data just down the component tree, and everything is fine. In case you have a very complex application with very dynamic behavior and unpredictable data needs, it's probably really better to co-locate your queries and pick a library like OmNext, for example. And nevertheless, even if you decided that you don't use OmNext or co-located queries, it might still be very beneficial for you to provide something like a powerful remote backend endpoint that understands GraphQL-like queries, because this might spare you lots of specific endpoints that you might program otherwise. So just assume that we don't want to solve this problem of unpredictable data needs because we don't have it. Then what other tools do we have in dealing with the problems about state organization? So one of the problems, or one of the tools that we have is Dataflow Programming. The core idea is that you have a single atom, and then you have some derived atoms, and you have functions between them. And every time that state in your single atom, so it's the single source of truth, that state changes there, then these functions are run and the derived state is recalculated. And in the optimal case, only in those cases where you actually need to recalculate something. This also solves a little bit of the problem that you have to show the same piece of information at very different places in your component hierarchy. So this is also a very powerful idea, and if you like to go with this, then I would recommend that you take a closer look to Reframe, which is built on top of Reagent, because it gives an implementation of this idea. Okay, one caveat or one drawback is with Dataflow that your components that sit on derived state have no idea anymore of where updates have to be applied. So just because they look at derived state, they cannot know by any means where the original state was and where the update has to be applied. So in case you need those components to be reusable, for example, they have to take more parameters so they can actually communicate where updates have to be applied to the single source of truth atom. Another tool that we have are cursors. They are quite simple idea, but quite powerful. And they greatly help when you have a very simple style of single-page application. Cursors just combine a pointer to an atom together with a path. And you can derive new cursors or new values of such a cursor in a very cheap manner. And therefore, you can push down data, a component tree. And each component in this tree then knows where exactly it looks within the single atom. So in case this component has to communicate some events about state updates, then it just can take the path from the cursor and communicate it to the outside sitting code. So this is a very, very easy, very simple way, and it's very effective. But it doesn't work anymore if you have components that look at derived state in case you're using something like Dataflow. So both of these approaches are not composable by themselves. So what about your decisions? So the first decision I would take is, do I really have the problem of heavyweight and expensive transformations of state in my application? If yes, then you should take a closer look to some kind of data flow solution. For example, take a look at Reframe. And then you need to decide whether your components must be in any means reusable. Because if they have to be reusable and they have to sit on derived state, then you have to give them additional information so they can communicate where state changes have to be applied. In the other case, so in the simple case, I would just stick to one single atom, use cursors, and everything more or less falls into place. Okay, so that's it for state organization. Now I come to the other topic, which is state synchronization with the remote backend. First of all, since we're in the browser and we have to do remote calls, we get the response in a callback. So we have an asynchronous scenario here. And the first thing I would decide, or I would choose to do, is if you receive an answer, a response from a remote backend, just treat it as an event and put it into your big event loop in the channel so that you can treat it uniformly by your presentation logic. So that makes communication with your backend relatively painless and seamless because you just have this dispatcher and this logic to decide what you want to do with the response anyway in your application. There's a certain little problem that you have to be aware of, which is just imagine that the user has an entity in the front end, and he starts to edit it and saves an update, and the front end sends the data to the back end. Then the back end, for some reason, rejects the update. Now you have the situation that the front end has one version of the state, and the back end has another one. So you have an inconsistent situation. And in this case, it would be very nice and very convenient if you are able to just bundle several requests in one network round trip. So this is something that we often do. So in case that we send updates from the front end to the back end, we send in the same network round trip a request or a query for the updated data. So we get the updated data always back after we send an update. And therefore, in case of errors, we can override the state in the front end to create a consistent situation again. This solves this problem, but it opens up another problem, because what happens if your user continues working with the entity once it has been sent to the backend? Basically, the problem is she or he might have edited some field, then the response from the backend with the updated state comes back and overrides what the user has just edited. So this is quite annoying, and you have, in my opinion, basically two options. You can decide that you don't want to allow this, so you just block the user's interface whenever you start communication with your backend. But this might be a bit too annoying for your users. So if this is really a problem for your users, then you have, I think, no other option than to implement a merge algorithm that tries to merge what the backend has returned with what the user has currently edited. And then we have a last small problem, and this has basically to do with having state in the front end and in the back end, and allowing users to edit the same entity simultaneously. So this is a classical problem in distributed applications, and the precise problem here is that when user A, for example, user B here has sent an update, then an update sent by user B sometime later might override what user A has done. So this is a lost update problem there. And the classical approaches to solve this problem are pessimistic and optimistic concurrency control. So optimistic concurrency control means that you apply or you add a version number to your entities, and you might want to store them also in the backend and in the database. And now whenever an update is sent back from the front end to the backend compares the current version number with the new version number, and if they match, the update is applied, and if they don't match, the update is rejected. So this is basically how concurrency control in the optimistic way works. This is very nice when you have low probability of conflicts, or if it's okay for your users to retype or rework what they have just sent to the backend. The other approach that is commonly used is locking. So it's also called pessimistic concurrency control. And locking basically means that before a user can edit something, she or he must to acquire a lock, and the backend then takes care that only one user at a time has a lock for a certain entity. And after the update has been saved, the lock is then released. This is another way of solving concurrency problems. And now you have to make a decision which way you want to go, and it really depends on your domain and what is acceptable for your users. So in my opinion, implementing optimistic concurrency control or version numbers is a bit cheaper, and it might only be very annoying if conflicts are very likely. If it's not acceptable for your users to retype or rework anything what they have just sent, then I think you have to go down the way and implement lock management, which is a bit more complicated than optimistic concurrency control. And it includes also that you have to detect when your clients die, because then you have to release their logs automatically. So it's a bit more complicated. There are more chances of introducing bugs. So you should consider very closely if this is the right option for you. But these are basically the two ways that you have for concurrency control. So that's it for the two areas of problems that I wanted to cover. Now we have learned something about state management and state organization and how to communicate state between front end and back end. We have seen how data flow or cursors or even co-located queries can help. And last but not least, I'd like to give you 3 little advices. Before you start picking your favorite library for a single page application on top of React, please closely examine if unpredictable data is something that you have as problem or not. Because if you have it, then you should pick something like an approach that Next implements, because it greatly helps to solve all these problems. But if it's not your problem, then you should stick to simpler solutions. The next question that you should ask yourself is, do you need expensive data transformations? If yes, then you should pick Dataflow, or as a concrete implementation, something like Reframe. If not, then you can make your application even simpler. And please, if you have already picked your library, then please closely examine what kind of decisions and trade-offs it has made on behalf of you, because sooner or later they might bite you, and I think you want to find out at the earliest possible time. Okay, so that's it for me. Now happy to take your questions.
Thank you, Falko. So if you have any questions, please raise your hand. I will bring you the microphone such that we have it on tape.
Okay, you said several times you have to make a choice depending on what your needs are. Like, for example, data flow versus cursors. And it often happens that in the course of the development of a project, you realize that it's not one that you needed, but the other one. And I guess it happens pretty much all the time. Have you faced this kind of situation? And how easy is it to move from one approach to the other one?
Yeah.
Or is it best to just stick to the approach and deal with it? Or is it best to move? Or?
Well, that's really a tough question, because you should have as much knowledge in advance as possible to make the good decision. And in ORM, for example, you have a way to link to some state somewhere else in the single atom that you usually can't access as a component. So there are sometimes options that a certain library gives you, but if data transformation, or if having to reference the same piece of information in very different places is really at the core of your problem, then you should not start with ORM and cursors, for example. So you should in advance have a rough feeling about what direction will your application take. That's the best advice I can give you. So I think it's not very easy to switch once you have detected that you're on the wrong way.
So I think we have time for one last question until we move on, since we started later.
You talked about in the component when you have to dispatch an event, for example, but the component itself is stupid, so you must have a way to receive the channel or the dispatch function. Right. How do you do that? Do you use props, or you leverage something like a React context, or?
There are several ways that you can do it, but we usually just pass the channel in as a parameter. So in Reagent, you can just take it as a regular parameter in the component. You can use in ORM, for example, something that is called, I think it's the props. You have a way of just passing in props.
So it's something that you have to that has to go through all the the view.
Yeah.
All right. Thanks.
So thank you very much, Falko.
Yep, you're welcome.
And we will shortly continue.